we will discuss another problem on friction, block friction. This is also an examination problem, March 2022 VTU. So he has given a diagram like this. You have two blocks A and B. Block A is resting on block B, like this. So this is block B. Block A is resting on block B. And of course, block A is connected to this wall by a string. And a force P is applied on block B in this direction, in left direction. Now the question here is, find the force P. Find P to have impending motion. To have impending motion of block B. Block B. He has given also find the tension in the string. Also find tension in the string. Always cables and strings, they carry tension forces. The weight of block A is given as 500 Newton. Weight of block A is 500 Newton, whereas weight of block B is 1000 Newton. Weight of block B is 1000 Newton, and of course all are rough surfaces. So he has given the coefficient of friction for all the contact surfaces as 0.2 for all contact surfaces. So this is the problem given. So we have to find two things. One is the force P, we have to find out. Another one is the tension in the string. Always please note that tension in the string acts away from the joint. We have to show like this. So T is the tension in the string. Now here he has given the direction of P here. So by knowing the direction of force P, you can decide in which direction the impending motion will start. So of course, since block B is pulled towards left, naturally the direction of motion of block B will be towards left. So I will take block B, free-body diagram of block B now. So please be careful here. Weight of this block B is how much? This is 1000 Newton. Weight of block B is 1000 Newton. It is given. So direction of motion of block B will be towards left because force P is given towards left. Therefore, direction of motion will be towards left. Naturally, the contact surface, there are two contact surfaces for this block B. One is this contact surface, another is this contact surface. So at this contact, both the contact surfaces, so since the direction of motion is like this, frictional force will be acting in the opposite direction at both the contact surfaces. But since the contact surfaces are different, let me take those frictional forces at the contact surfaces F1 and F2. Normal reactions also will develop. It will be like this. This I will take as N1, and here the normal reaction will be like this. This is N2. So this is the free body diagram of the block B. Weight of the block is 1000 Newton. Now we have to apply the equilibrium equations to analyze this. Now we know that the relationship between F1 and N is F1 is equal to mu times N1. Mu is given as 0.2. So 0.2 times N1. Here it is mu times N2. Since mu is same, we have to take the value of mu at both the contact surfaces is 0.2. Now let us apply the equilibrium equations for this. So this is the free body diagram of block B. So I will apply sigma Fx is equal to 0. So please note that in the direction of motion, I will take it as x-axis, and perpendicular to that, I will take it as y-axis. So what is positive, what is negative, you have to decide based on the direction of x and y. Now sigma Fx is equal to 0. Here I have taken this as positive x direction. Therefore, x is positive towards left here. So P is positive. Then you have this F1 is negative, F1 is nothing but 0.2 times N1, that is negative. Similarly, F2 negative opposite direction, 0.2 times N2. So this will be equal to 0. There is no other force in the x direction. So you can call this as equation 1. You cannot solve this. There are 3 unknowns. Now the second equilibrium equation is sigma Fy is equal to 0. Of course, upward positive, downward negative. So N1 is positive but N2 is negative. So N1 minus N2, and this 1000 Newton is there which is negative downwards. So minus 1000 is equal to 0. So this is the second equation you have got. So we cannot solve this also. There are 3 unknowns, 2 equations. Now the another set of equations we can write by taking the free body diagram of block A now. So let me take the free body diagram of block A now, and I will apply the equations for this. This is block A. Weight of this block A is 500 Newton. You have to go down. One thing you should be very careful here. When you take this contact surface between A and B, for this block B, this F2 is acting in this direction. Please, you should be very careful here. F2 is acting like this. For block A, it will be in the opposite direction. Same F2 will be there, but it is magnitude is same, but it will act in the opposite direction. So what I have to take here is F2 will be like this. For block A, F2 will be like this. F2 is once again nothing but mu times N2, which is nothing but 0.2 times N2, and normal reaction as usual it will be like this. This is normal reaction N2. And here this A is connected to the wall by a string. So that also we have to take. So this string, in this string you have a tension force. Of course, he has given the angle as 30 degrees. So this has 30 degrees. The string is connected with an angle 30 degrees. That means this angle is 30 degrees. Now once this angle is known, you can resolve this into 2 components. So the thing here is when the block B moves in this direction, block A will move in the opposite direction. So that is why friction will be there in this direction. So direction of motion is like this for block A, opposite to that of block B. So therefore your F will act like this. So I have taken the frictional force at this contact surface between A and B, and normal reaction will be like this. Then this tension force in the string, that is also connected to A. So that is T. I have taken T as the tension force in the string. Now here for this we have to apply the equilibrium equations. So before that I will just resolve this. This becomes T cos 30 and this becomes T sin 30. And the x-axis, as already told, direction of motion, I have taken x-axis perpendicular to that y-axis. Now let us apply the equations for this for block A. Sigma Fx0 towards right positive, left negative. So this F2 is acting towards left. So minus 0.2 times N2, that is minus F2 is equal minus 0.2 times N2. Then this is positive plus T cos 30 is equal to 0. So this is one equation. They can call this as equation 3. Now the second equilibrium equation, sigma Fy is equal to 0, upward positive, that is y direction positive like this, downward negative. So N2 will be positive, T sin 30 is also positive, plus T sin 30 is equal to 0. Plus T sin 30, then it is minus 500. Minus 500, that is the rate of the block, is equal to 0. So this is the fourth equation. Now you can see, if you observe these 4 equations, there are 4 unknowns, N1, N2, P and T. So you have 4 unknowns and 4 equations. Definitely you can solve. Number of unknowns is equal to number of equations. So you can solve the equations now. So these are the unknowns. So once you solve these equations, you will get the values of all the normal reactions as well as tension in the string and the P value. Now only thing is how to solve this. So elimination method we have to adopt. So how to do that? So let us see. So here, if you observe these two equations, N2 and T only two are the unknowns. We can solve these two equations, simultaneous equations we can solve. So here, the first equation, of course, equation 3 can be written as, so what I can write equation 3 as, if you want this N2 value, N2 is equal to T cos 30 divided by 0.2. Okay. So cos 30 divided by 0.2 into T. So let us see what is that constant we are going to get. So T cos 30 divided by 0.2, it will be 4.33. So 4.33 times T is N2. Now substitute this in equation 4. If you substitute this in equation 4, what you will get here is N2 is 4.33T. 4.33T, okay, plus T sin 30 is equal to 500. So somehow or the other we have to solve the equations. So here sin 30 is half, so this is 0.5, 0.5 plus 4.33, 4.83 T is equal to 500. Therefore, T is equal to 500 divided by 4.83. So which is 103.52. 103.52 newtons. So this is the tension in the string. So one value we got. Then substitute that value of T here. Here you will get the value of N2. So I will do that here. So N2 is equal to 4.33 times T means it is 103.52. So if you multiply that, 103.52 into 4.33 will be 448.24. 448.24 newtons. So this is the value of N2. So N2 value and T values we have got using that equations 3 and 4. Now once you know N2 and T values, you can just substitute that N2 value here to get N1 value, and then substitute that value of N1 and N2 here to get the P value. So then we got all the 4 unknown values now. So now what I have to do here is substituting for N2 in equation 2. So continue that, substituting for N2 in equation 2, second equation, this is elimination method, Gaussian elimination method. So N1 will be N2 plus 1000. N2 plus 1000. So N2 is here 448.24. Therefore plus 1000 means 1448.24 newtons. So this is the value of N1. Now substitute this N1 and N2 in equation 1. Substituting for N1 and N2 in equation 1, you can get the value of P that is required to move the block P in the direction of P. So P is equal to 0.2 times N1. So 0.2 times 1448.24 plus 0.2 times N2. So N2 is 448.24. 448.24. If you simplify this, so you will be getting 1448.24 plus 448.24 into 0.2, so which is 379.296. 379.296 newtons. So this is the minimum force that is required for impending motion of block B. So when you apply a force 379.296 Newton, then the block B starts impending motion towards left. So this is how we have to solve the problem. So whenever one block is resting on another block, at the junction of the contact surface between two blocks, one frictional force opposite directions. So to understand that concept, this problem has been analyzed.